Now that everything's working again, let's look at some examples. So here's PCl3. So chlorine, being a halogen, is -1. Phosphorus is not an atom that we have in our list that we just put together. So what do we do with phosphorus? Well, we add up the chlorines. There's 3 of them. Each of them has an oxidation of -1. So that's a total of -3. In order for this compound to be overall neutral, the phosphorus would have to offset that and have an oxidation number of +3. How about So3 Sulfur Trioxide? Again, the oxygen is -2. There's 3 of them, so that's a total of -6. Again, the entire compound is neutral, so in order to offset that, 3 times -2 is -6. In order for this to be neutral overall, we would need a +6 for sulfur. All right, how about diarsenic trioxide? What would you come up with there? So again, oxygen is -2. 3 of them total to -6. But now the arsenic is not going to be +6 because there's 2 of them. And we can distribute that +6 that we need over the 2 arsenics. So each one would have to be +3. And let's do one more, KMnO4, potassium permanganate. Again, we know oxygen is -2. Potassium, being one of our group 1 alkali metals, is +1. So we have a total of +1 from the potassium and -8 from the 4 oxygens, means a total of -7. In order for the overall compound to be neutral, the manganese is going to have to be +7. All right, now how does this help us? Well, let's look at a reaction now. So this is the reaction of ammonia with oxygen to form nitrous acid and water. So what would be oxidized and what would be reduced here? Well, we go through the same series of steps that we did before. Hydrogen we know is +1. To offset that, we'd need nitrogen here to be -3. Oxygen here is in its elemental state as oxygen gas, so that means the oxygen is 0. On the product side, hydrogen in water is +1. We have 2 of those. That equals out with the -2 of oxygen. And in our nitrous acid, again, oxygen -2 and hydrogen is +1. In order to make this compound overall neutral, the nitrogen would need to be +3. So now where is our oxidation and where is our reduction? Well, nitrogen starts at -3 and ends up at +3. So nitrogen has lost electrons. It's been oxidized. Oxygen, on the other hand, started at 0 and ended up at -2. So the oxygen has gained electrons and therefore been reduced. All right, the final step for this is to learn how to balance redox reactions. So balancing redox reactions is different from balancing the types of reactions we learned much earlier in this course. In some ways it's a lot easier. In some ways it's a lot harder. The reason I say that is it can be a lot harder because there's a lot of steps that you have to learn to do this. But the reason it can be easier is there's no sort of some of those weird steps that we had in balancing some of the harder equations that we did. This is a very systematic way to do it. And so I'm going to sort of outline what the steps are and then go through two examples. So 1, split into two half reactions. And that's the oxidation and the reduction half reactions. 2, balance everything except hydrogen and oxygen. 3, add water to balance oxygen. 4, add H plus to balance hydrogen. 5, add electrons to balance charge. 6, multiply equations to balance electrons. Or maybe a better way to say this maybe is multiply half reactions. And we do this so that electrons are equal. 7, add the reactions. And 8, if basic conditions, use OH minus or hydroxide to offset H plus. All right, so let's do an example now. So we're going to balance the reaction of permanganate, MO4 minus, plus bromide to give us manganese 2 plus bromine. So first step, split this up into its half reactions. How do we determine what are the half reactions? Well, we look for the compounds that are in common, the non-hydrogen, non-oxygen. So manganese, we put the manganeses in one half reaction and the bromines in the other. All right, balance these half reactions for non-hydrogen and non-oxygen. Our first one we don't have to do anything with because we have one manganese on each side. The second one though, we need to add a 2 to balance bromine. Next step, add water to balance oxygen. So our first half reaction has 4 oxygens on the left, but none on the right. So we need 4 waters. That balances oxygen. Second reaction has no oxygen, so we don't have to worry about it. Next step, add H plus to balance hydrogen. Again, the bromine half reaction doesn't have any hydrogen, so we don't have to worry about that. But the other one now has 8 hydrogens from the 4 water molecules on the right, so we need to add 8 H plus. Now we balance the charges by adding electrons. Let's do the second reaction first, because that one's actually an easier one. So on the right we have 2 Br minus, so we have a total of a -2 charge on the left. On the right, the charge is neutral. So to make the right -2 also, we add 2 electrons. For the one above, our right side adds up to +2 for the 2 manganese. The left side has -1 for the permanganate, but +8 from the 8H plus for a total of +7. So to make those equal, we add 5 electrons. Now our 2 half reactions have a different number of electrons, and we need those to be equal. In order to make those equal, we're going to have to multiply both reactions to get those numbers of electrons equal. So if we multiply the first reaction by 2, that gives us 10 electrons. And that means we have to multiply everything by 2. For the second reaction, if we multiply it by 5, we also get 10 electrons. Now we can add the 2 equations together, and we cancel anything that's the same on both sides. Now in this case, the only thing that's going to cancel are the electrons. But we get 10 Br minus plus 16 H plus 2 permanganate reacts to form 2 Mn 2 plus 8 water plus 5 bromine. And so our equation is now balanced. But it's important to notice that this is balanced under acidic conditions. What if we wanted to balance this under basic conditions? How would we do that? Well, that's where our last step comes into play. So let's copy this over. Maybe. All right, that doesn't want to copy, so let's just rewrite that. So how do we balance and how do we get rid of the acidic conditions? Well, what we do is we add hydroxide. And we add enough hydroxide to offset all of the H plus. And just like with a mathematical equation, as long as we add something the same to both sides, it doesn't affect what we're working on. So I can add 16 hydroxide to each side, and I don't change the actual experiment. Now what happens is on the left side now, we have 16H plus and 16 hydroxide. And so those will combine to form 16 water. So now we get 16 water plus 10 bromide plus 2 permanganate gives us 2 manganese 2 plus 8 water plus 5 bromine plus 16 hydroxide. But notice now we've got water on both sides. And so what we can do is cancel out as many as we can. So these 8 will go away, and that'll take away 8 on this side and give us 8 here. So our final balance equation under basic conditions is 8 water plus 10 bromide plus 2 permanganate reacts to form 2 manganese 2 plus 5 bromine plus 16 hydroxide. So this is balanced under basic conditions, and just to make the note, the one on the previous page, this was balanced under acidic conditions. So a lot of steps here, but the reason I sometimes find this easier than just the types of equations we had to balance previously is this is very, very systematic. There's no having to sort of go back and forth and maybe take a guess here and try this and maybe this works and maybe it doesn't. It actually ends up being a lot easier. So let's do one more. So we're going to do ClO minus hypochlorite plus iron hydroxide to form Cl minus plus FeO4 2 minus. So again, first step, make your 2 half reactions. Oh, and I'm sorry, we're going to do this under basic conditions. So ClO minus is one of our starting materials. Its product is going to be the other chlorine containing compound, which is Cl minus. And our second half reaction is iron hydroxide to form FeO4 2 minus. All right, our first step here ends up being very, very easy. Let's balance all of the non-hydrogen and oxygens. Why is that easy? Well, there aren't any. Or, I'm sorry, they're already balanced. Chlorine is 1 chlorine, 1 chlorine, 1 iron, 1 iron. All right, now we balance oxygens by adding water. Our first reaction needs 1 water on the right. Now we have 1 oxygen on each side. In our second reaction, though, we start with 3 oxygens on the left versus 4 on the right. So we need 1 more water over here. Now we can go on to H+. In order to balance H+, we need 2 hydrogens on the left here. For our second half reaction, we have 3 hydrogens from the hydroxides plus 2 from the water is a total of 5. Now we balance our electrons. Total charge in the first half reaction is -1 on the right, but +1 on the left. So we need 2 electrons on the left. For the second example, we have a total of +3 on the left, so we need 3 electrons. Now we're going to multiply the first equation by 3, which would give us 6 electrons, and the second equation by 2 to also give us 6 electrons. Now that we have equal numbers of electrons, we can add our 2 equations together. And I'm just going to eliminate the electrons. They cancel out. Now, before we go on to our last step, notice we have H plus on both sides and we have water on both sides. So we can do some canceling. There's 2 waters here on the left, 3 on the right, so we can eliminate 2 from each side. Also, there's 6H plus over here versus 10 on the right. So we can cancel out 6 on each side, so that goes away, and this one becomes 4. So what we're left with, 3ClO minus plus 2 iron hydroxide reacts to form 3Cl minus plus water plus 2 Fe4O4 2 minus plus 4H plus. Now, if we've done everything correctly, everything should be balanced. And you can see we have 6 hydrogens on each side. We have 6 oxygens on each side, 2 irons, and 3 chlorines. No, I'm sorry, that's 9 oxygens on each side. So yes, we are balanced. We also have a total of -3 charge on each side. So everything's balanced. Last thing we need to do in order to make this under basic conditions. So if we were balancing this one under acidic conditions, at this point we would be done. Under basic conditions though, recall we're going to add 4 hydroxide to offset the 4H plus to each side. So that's 4 hydroxide plus what's already on the starting material side. And remember, those 4 hydroxides are going to combine with the 4H plus to form 4 water molecules. Now we already have 1 water on that side, so we can just get rid of this and combine it with the one that was already there. And now we have this successfully balanced under basic conditions. So that actually is the end of the lectures. There's one more practice exercise for you to work on. It's the one labeled redox, balancing redox reactions. I believe that's number 23. Yes, number 23. So you should work through that, and then we'll have one final video which will go through and discuss how to work on those.